All right, welcome to chapter 6.2, the definite integral. So I want to talk very quickly as an introduction about something that you probably do remember, which is differentiation. And then we're going to talk about how that relates to integration. What's the difference? What are the similarities? So let's very quickly talk about differentiation. I've got some function here. And differentiation said if I take 2 points on the graph, a and a plus h, and therefore I have two y values, f of a and f of a plus h, that the slope of the tangent, or excuse me, the secant line, the slope of this secant line could be found by taking the change in y over the change in x. So what I then did is I started to move this point closer and closer and closer, and I took the limit as h went to 0. And when we took the limit as h approached 0 of this slope, what we got was the derivative at a. So both rates of change. This is in red is the rate of change of that secant line between 2 points. And the green is the rate of change at that point because we take the limit as h gets infinitesimally small. And the key here, when we're talking about differentiation, it is this limit as h goes to 0 that makes the difference between just the slope of a line versus the tangent line, the slope of a point on the line. So now let's introduce differentiation. Let's go, or excuse me, integration. And the last section in the book, you were looking at these same functions, and we had some boundary A and another boundary B, and we said we're interested in the area under the curve. And what we did to find the area under that curve, is we said, this is complicated. We don't know how to find the area of that shape. It's an irregular shape. But what we could do is we could split it up into rectangles and we can find the area of each of those rectangles. So we had some little change in x, and we'll talk a little bit more about that as we go along. We had some point, let me do that as a different color. We had some value of x that we chose, midpoint, left, right, whatever it was, and we said, oh, well, then the area of that rectangle is that y value times the change in x, and we added all the rectangles. We took the sum of the rectangle areas. And it is this idea of a sum that is going to be really important when we talk about integration moving forward. So let's take a little side trip. Let's talk about something called sigma notation. And sigma is the Greek letter S. Capital sigma looks like a big spiky capital E. And it represents the sum. Sigma represents the sum. So if I'm adding up all of those rectangles from the previous problem, I could write it as the sum sigma of all the rectangles. So let's look at a little bit of notation. First off, if I write sigma I equals 1 to 6 of I, that means that I'm adding up all these values of I. This would be 1 plus 2 plus 3 plus 4 plus 5 plus 6. And that's equal to 21. So the sum from I equals 1 to 6 of I is 21. Let's look at a slightly different example. I'm going to go the sum of from k equals 2 to 4 of 1 over k squared. So instead of just adding up all of the numbers that are in our indices here, we're actually doing something to those numbers. So this is 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared. K goes from 2 to 4, 2, 3, 4, and I am taking the reciprocal of the square of each one. And if I add all those up, I get 61 144ths. So this notation, what we're going to be doing in the next video is we're going to come back and we're going to say, well, let's figure out a way to write the sum of all the rectangles. And then we're going to say, well, then let's figure out a way to make it easier. Just like we did with derivatives, we're going to figure out the basics of integrals, and then we're going to say, okay, now let's make it easier. Okay, so I'm going to stop right there. I'm trying to keep these videos short, but you know two things at this point. You know what we mean by integration, which is adding up the areas of the rectangles, and you know that we've got this sigma notation that represents adding them all up that we're going to be able to use, and we'll be back with the second video to go into more detail. Thanks for watching.